right, good morning and happy Friday. So last time I left a lesson for you guys. It was pretty big in terms of lots of attachments and lots of pieces to it. The reason I ended up doing that was because it sort of all fit together with the same topic, and I didn't really want to break it into two pieces. It just seemed more natural to leave it like that and then do something smaller today. So I put down, normally when we begin units, when we're in school, I would give you a sheet like this for the unit and sort of show you what the big ideas are or the main things we want to cover. We have been hitting at several of these. So we've talked about how a piece of technology using light has been beneficial. We've talked about how a device or procedure can alter how the human perceives light. That was most of what I was doing on Wednesday. We've talked about different sources of light. We've talked about naturally occurring phenomenon like colors and shadows and things like that, rainbows and such. We'll keep adding to that little list. But today and going into next week, we're going to start working, at least for today for sure, on this point, which means you're going to learn what ray diagrams are, specifically related to lenses first, and then some of the things we use lenses for. And then when we're done talking about all the different lenses and some of the uses of lenses, we'll move on to mirrors, which is this thing right here. In doing these, we're going to talk about reflection, refraction, which is the last part. So don't worry about copying all that down. I just sort of wanted to frame what we're doing and how I've picked the key things that I want you to learn while we're on this kind of modified program. Okay. So I introduced to you on Wednesday the idea that you can have glass that is just straight up and down, a plain face, they call that, or you can use curved pieces of glass. We call these lenses, and there's two sort of shapes that we're going to deal with. The one is where it bulges out in the middle. That's called a converging lens. And the other is where it pinches in at the middle, when we call that a diverging lens. So the one in your eye is converging. That's the one we've talked about the most so far because of the eye. I'm going to build on that today and specifically just do a little bit on the converging lens and talk about why it is that when you have light coming at you from the outside world, as it goes through this lens, it gets flipped upside down, and why that image on the retina on the back of your eye is upside down. So we're going to get started. We're going to have to draw a little bit today. I looked around for a ruler. I didn't have one. So I'm just going to use like the edge of this case. You could use another piece of paper or something like that to help you draw the straight lines and do the best you can. Oh, I'm trying to get comfortable here. Okay, so we're going to call the title for this note today Converging Lenses. Okay. Ray diagrams. So we're using that model of light, the ray model of light, to do these pictures. Okay, so there's going to be some general pieces to this that I won't repeat each time, but some new vocabulary and terminology to go with this. So the first thing you want to do, this is going to be tricky for me, is to draw several lines down, like 4 or 5 lines down, let's say. I don't know if I do like this. Straight line. Okay, all the way across. And then I'm going to put a converging lens somewhere along this line. So I am going to do my best here. Let's say that this, let's try to do a dash line here to kind of show where the middle of the lens is going to be. Then I'm going to try and freehand here. And because I want it to be converging, I'm going to bulge out and come back in. Bulge out, come back in. In a perfect world, that would look the same. It'd be symmetrical. Not so much. Okay, so this is a piece of glass which bulges in the middle. We call this center part of the glass right here, just try to label here. We call this the optical center. You know that the name of this unit is optics. So everything we're talking about has to do with light and how light works. You might know that people who work on the eye are optometrists. You might know that people who make and put your glasses together, opticians. So all that stuff is connected to that. Ophthalmologists or eye doctors, and it goes on and on and on and on. Okay, so the middle of this piece of glass is called the optical center. Because this is a piece of glass, or it could be plastic as well, it's a transparent material. The light can travel through it both ways. So if I shine the light over here, it's going to go through and you'll have it pass through the other side. If I shine the light here, same thing, it would pass and go through the other side because it is transparent. This line here that we drew to start, that we've centered the lens on, is called the principal axis. Principal spelled P-R-I-N-C-I-P-A-L, axis. Okay, the line through which the optical center of the lens goes, I'll put that here, travels through middle of a lens. Okay, and that means like middle in terms of widthwise and middle in terms of top to bottom, the perfect center of that piece of glass or plastic that's transparent and shaped that way. All right, now I am going to put, let's see, this would be helpful to have a ruler. I'm going to put a dot here and one on this other side, and it should be the same distance. Okay, and I'm going to call that F, and F on the other side too. That would be a distance we could actually measure. So maybe that would be like 2 centimeters, 2 centimeters. Same for both out from the optical center. What that F stands for is the focal point, F-O-C-A-L, point. And I have one on both sides, and it is where light rays converge. So we looked at this lens the other day, and as light rays come in, they sort of all come to the same point on the other side. So why you have one on both sides? It's because it depends on where the light comes from. So if light is coming from over here, it's going to go through, and all those rays are going to converge and cross at this point. If light was coming from this way, then the light rays would go through, and they'd all converge, meet at this point. Okay, so it's only because it's glass and because you could have it go from either way. There's a focal point, same distance from the center, on both sides of that middle piece called the optical center. This line I drew right here through the middle is called the axis. Axis and axis. So this one is horizontal, this one is vertical, of symmetry. So the middle of the glass in terms of left to right. Okay, so that center. All right, so let's put an object on here. I'm going to use my pencil for this. So let's say I'm going to do a tree just because it's so simple to draw. Arrows are pretty common as well, but I'm going to do like a little tree today. So let's say I draw, where do I want to put it here? Let's do right here. I'll do it up to this line. You know what? I'm just going to do an arrow. Let's pretend that's the top of a tree and the bottom of the tree. Okay, now here is where a real ruler would be really helpful. You need at least 2 lines to find where the image is on the other side of the glass and what that image looks like. So I'm going to teach you how to do 3, but at least 2 to find and describe the image. So what that looks like after the light goes through the glass on the other side. So we've talked about how in the eye, you look at something from the outside world, it goes through this shape of lens in your eye, and on the retina, it is upside down. Okay, so let's see if that is true in this situation. So first thing is one of the lines you can choose to do, I'm going to scrap even this one, is to go straight. If you have a ruler, use a ruler until you hit the middle of the glass like this. I'm going to put a little arrow there to show the light ray is headed in this direction. Okay. And then for light rays that travel parallel to the principal axis, when they come and they hit the middle of the glass, it's actually not quite true. They bend a bit here and bend a bit here, but for our purposes, just go to the middle. And then when it comes out the other side, it's going to head towards this focal point, F, and keep going. So I'm just going to shift this a little. Going to line up with that point and that point. And the key is keep the light ray going past the focal point. Okay. So this bent the light. It continues to go straight, just in a slightly different direction. We call that refraction. We're going to come back to that word later. Okay, now let's say that for our second line, we chose to go through the focal point on this side on the way to the lens. So it has to be a straight line. I'm going to line it up with the same point on the object. It's going to go through F on this side, and it's going to hit that axis. Okay. When this happens, if it hits the lens after coming through F, it turns and goes parallel to the principal axis. So I'm going to connect there. Okay. So that should have been parallel to that. Looks like I'm off just slightly. So you can see those two lines have crossed at a certain point. That is enough to find the image. So then when I go to draw this, I'm not happy with that. Why aren't I happy with, oh, that's why. Okay. I'm gonna go like this. And that, where they crossed, is the same part of the object that I started from. So we have this upside down over here. Okay, so that explains why when the image hits your retina, it is upside down. Okay, the third line you could use is the following. If any line goes through the optical center, it just keeps going straight. So if I started from the top of that object and go through, oh, I just made it slide. Let's try that again. And go through the optical center, I should hit the same point over here where my other two lines crossed. Okay. So what I could have done is I could have gone parallel, turned and gone through F, and then used the optical center line to find the image. I could have used the optical center line, gone through F, and then turned parallel to find the image, or I could have used the top one and the bottom one. Any of those situations will get you to the same image. Okay, so let's just write the general rules of how to do this. So one of the lines you can use is any ray traveling parallel to the axis. So the first one I did is refracted, which means it turns its direction, is refracted through F. Okay, on the other side. The middle line here, any ray traveling through the optical center continues in a straight line. Option number 3, any ray that travels through F is refracted and goes parallel to the axis. And then I'm going to put a star here. You need 2 lines to find the image. Okay. All right. So that's the basics of it. I might just stop there for today, actually, and let you digest that and take a look at that. And then what I'm going to do next week is do much more with ray diagrams. So then we'll start to look at what if we slide this way or this way, how does it change the size of this? Properties we have for images. We call them, like, we can describe the image in terms of its size, its attitude, its location, and whether or not it's something we call real and virtual. So that's where we're going to head next. In terms of stuff to follow up this lesson, I'm just going to leave you something very general about any kind of connection you've made with the work we've done so far. All right, so if you do have a ruler for next week, that is great. I don't even know if I'm going to have a ruler. We can get by without it. But when you're drawing these, precision does matter. So trying to make straight lines and make sure that you turn them to be parallel or start with them parallel, and all those pieces matter. Otherwise, they won't cross at a point, and then you'll be left confused about where your image is. They should be crossing so that you'll get that connection to find the top of your object. Okay. All right. I guess that is it for now. Whatever your weekend looks like, I hope it's a good one. Please let me know if anything is going on, if I'm giving too much work, too little work, if you're having trouble accessing the lessons, if I need to do something differently. And I am more than happy to do that. Okay? All right. I think that's it for now. So I will say goodbye.